Hi there, this is Penelope and this is Topic 13, Class 1 on complex numbers. Now, in this section, in this video, we're going to look at the arithmetic of complex numbers and then we'll move on to the Argon diagrams and polar forms in the second video. Now, you might think, why do we need to study complex numbers for engineering? Well, complex numbers are the biggest set of numbers. All of the other numbers that you can possibly think of come within the set of complex numbers. Natural numbers, whole numbers, integers, rational and irrational numbers, all of them come within the set of complex numbers. So they really are important. Now, we define an imaginary number or a complex number, a complex number to be defined as the square root of -1. Now, all the way through we've said, you can't take the square root of a negative number. Well, you can if we define it to be, and mathematicians define it as an I and engineers define it as a J. And all it is, it's a definition of the square root of a negative number. Now, you might be tempted to say that I squared equals 1, but actually that's not true. I squared is the square root of -1 times the square root of -1, which means that I squared is -1. So just watch out for that. That's a wee trap that you might fall into. So if we want to simplify, for example, the square root of -9, what we would write is that that was 9 times -1, which we could break up to being square root of 9 times the square root of -1, which gives us plus or minus 3 times the square root of -1, which we could call I, or plus or minus the square root of 3j, or sometimes engineers write the j first. And if we look at, say, the square root of -18, the square root of -18 would be the square root of 9 times 2 times -1. So we could break that up into plus or minus 3 root 2 and put the j in the front if we're being engineers. Now, we add complex numbers in just the same way as we do ordinary numbers, and same with subtract. 16j minus 5j would give us 11j. We multiply them just the same way. 3 4s are 12, j squared, but remember that j squared or I squared is -1, so 12j squared becomes -12. What happens if we keep on multiplying? We've already done j squared is -1, and j cubed would be j times j times j, which would be, these two will give us -1 times j, so it would be -j. If we did j to the 4, it would be j times j times j times j, 1, 2, 3, 4, right? And each of those would be -1, so it would be -1 times -1, which is +1. When we're on to j5, we could look at that as being j to the power of 4 times j, and we've just worked out that j to the power of 4 is 1, and that would be 1 times j, that would be j. Looking at j to the 99, if we break that down to being j to the power of 96 times j to the power of 3, then j to the power of 6 is j to the power of 4 times 24 times j to the power of 3, and j to the power of 4 times 24, well, j to the power of 4 is 1, 1 to the power of 24 is still 1, times j to the power of 3, and we previously worked out that j to the power of 3 was -1. So we can do all of those. Now, previously we haven't been able to do this problem, so let's look at it now that we can. We'd say x squared equals -4, and x then equals plus or minus the square root of -4, which would be plus or minus j2 or 2j, depending on how you're going to write it. If we wanted to solve 2x squared plus 3x plus 5 equals 0, previously we couldn't have done it, but now we can if we say that x is going to be equal to negative 3 plus or minus the square root of b squared minus 4ac, which would give us negative 31 over 2a, which is over 4, then we could write that as x is equal to negative 3 over 4 plus or minus root 31 over 4j. Complex numbers are not particularly complex as in difficult. They are called complex numbers because they have two parts. They have a real part and they have an imaginary part. And so x, or sometimes z, is the complex number. We can add complex numbers by adding the real parts and by adding the imaginary parts. So for this one it would be 2 plus 1 is 3, and adding the imaginary parts, and we would get 3 minus 6j, which would be 3 minus 3j. If we're going to multiply them together, it's just using the FOIL rule, or smiley face, however you like to remember it. So it would be 2 times 1 minus 12j plus 3j minus 18j squared. So that would be 2 minus 12j plus 3j would be minus 9j, and j squared is negative 1. So negative 18 times negative 1 would be plus 18, and that would give us 20 minus 9j. So you see that a complex number times a complex number gives us another complex number. We can talk about complex numbers being equal. We don't need those page numbers. We talk about complex numbers being equal if their real parts are equal and if their complex parts are equal. The conjugate of a number is simply formed by changing the sign. So changing the sign in the middle, so 2 minus j3 has a conjugate of 2 plus j3. We could do division this way, and it's a nasty formula, and that would be where z1 equals a1 plus jb1 and z2 equals a2 plus jb2. But what is an easier way of doing this is that we say the division is multiplying by the complex conjugate. So if we've got 3 minus 4j over 7 plus 6j, to do the division we multiply top and bottom by the complex conjugate. Whoops, that's a 6. Because then on the bottom line what we get is 49 minus 42j plus 42j plus 6 times 6, which is 36, times negative j squared to give us plus 36. And on the top line we would say that would be 21 minus 18j minus 28j plus 24j squared. That would work that out. Then just a few problems here. z1 times z2 would be 1 minus j3 times negative 2 plus j5, and that would be 1 times negative 2, which would be negative 1, plus j5 plus 10j oops, that's not quite right, that's 6j there. There we are. And then plus j squared 15. And then we have 5j plus 6j, that would be 11j, and negative 1 plus j squared would be 14. Doing the division would be 1 minus j3 divided by negative 2 plus j5, which means you need to multiply that by the bottom line, which would be negative 2 minus j5 divided by negative 2 minus j5. And I haven't got enough space in there, but you could do that by multiplication. There's no difficulty in multiplying three things together. It would be no more difficult than multiplying three brackets together. Oops, what am I doing? Negative 2 plus j5 times negative 3 minus j4. So you'd have to multiply 2 together and multiply the result of that by the third one.